So broadly, the kind of goal and objective of Made in Space is to create the technologies and the tools that help people to sustainably live and work in space. And specifically for us, the thing that we focus on is actually manufacturing. Everything we've ever sent to space has gone up inside of a rocket. They also subject the things you send to space to an incredibly high G-forces and high shock and vibration forces, which means that we have to build the stuff that we send to space, that we put in this zero-G environment. We have to build them to survive this incredibly harsh environment. And we also have to take everything and kind of origami, fold it up, and put it in the top of the rocket in this kind of fairing that protects it as it goes into space. And as you fold that stuff up, you create opportunities for failure, and that's how we kind of arrived at doing manufacturing in space. And specifically, the first kind of technologies that we arrived at were doing 3D printing in space. We're proud to say that this isn't science fiction, that this is something that we're actually doing. And actually, so this picture you see right here is one of the former commanders of the International Space Station. He had lost his ratchet, while he was doing work on the International Space Station. So we actually were able to design up the file and send that to space. This ability to send things responsively to this really remote environment and really in some cases kind of save the day is really, really transformational. We worked with Braskem to develop a material that's 3D printable, that it is not made from oil. It's actually made from sugarcane, and it's a green polyethylene material. We launched the printer and some green polyethylene in March of 2016, and then we actually manufactured in space using this material. It's the first green polyethylene that's ever been used to do manufacturing in space. We're very proud to announce today that we're working with Braskem to develop a polyethylene recycling machine that will actually go to the International Space Station next year, and we will take waste plastic and objects we don't need to use anymore that are made of polyethylene, and actually recycle that material into 3D printer filament that then we'll put back into that printer that was just showing you, the additive manufacturing facility, and create new objects, forming this almost closed loop recycling system that will really, really reduce the impact from a mass and an operational perspective of having these parts on the International Space Station even more. Going on a deep space mission to the moon or going to Mars, this sort of recycling technology will be essential because we can't take everything we want to take with us. We're going to need to take a limited amount of material and take digital files of the different designs of the things that we might need, and then as the need arises, manufacture those objects, and then if we don't need those anymore, or if they break for some reason, recycle those back into filament so that we can use that, so we can manufacture something new. That level of kind of system level sustainability will be critical for people to ultimately go and explore space and to settle other planets and to settle the moon. What's the future look like? Really, it's about people sustainably living and working in space and sustainable operations on the final frontier.